Hello everybody, welcome to the Homework Helper for Stats 9.4. Let's go ahead and head into the Ready section. So for the Ready section, it wants us to fill in some two-way tables here. So we've got these two-way tables. We have all of this information. We've got first hour, second hour, third hour, and it tells us that a 60% or better is a pass. So what we have to do is we have to look into the data, find how many passes we have. So I'll go ahead and mark the passes in green. 60 or better. So here's 1, 2, not a pass, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So in first I had, did I just say 15? I don't remember. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 15 passes and 1 fail for a total of 16 students. Okay, do the same thing for second hour. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and 1 for 16. Let's do third hour. No. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 passes, 1, 2, 3, 4, 5, 6, 7 fails for 16. Okay. This gives me a grand total of 15 plus 15 is 30, so 39 passes. 1 plus 1 plus 7 is 9 fails. 39 plus 9 is 48 total students. So now I have my T-chart, not my T-chart, my two-way frequency table all set up. And then from here, we can begin to answer the other questions. What percentage of students pass Mrs. Hender's test in each class? So what is the total percent of all that pass? So it wants us to do first period, second, third, and total. So first period, 15 out of 16 passed. Second period, 15 out of 16 passed. Third period, 9 out of 16 passed for a total of 39 out of 48. So we're going to have to calculate these percentages. So let's go ahead and do that. 15 divided by 16 is 0.9375, so 93.75%. And that's the same in second period because it's the same numbers. For third period, 9 divided by 16 is a 56.25%. And then overall, 39 divided by 48 is a grand total of 81.25% passed. Awesome. It then wants us to create a histogram using technology. Sketch your histogram below. We don't have to necessarily use technology for this one, but what I would want you to do is when we're looking at the total data, to create a histogram, all that you do is you look at the total scores like so, and you break them up, and you do it by count. So when we're looking at this, we'll just say we'll group it by tens. Okay, so we'll do. I think the lowest I saw was a 40. Saw some 40s, right? So I'm going to start by looking at 40s, okay? So these are going to be my 40 to 49 histogram. Okay, that'll be here. 50 to 59. 60 to 69. 70 to 79. 80 to 89. And then 90 to 100. Okay, we'll include that extra 100. So all that I'm doing here is I'm just doing a count of my data. So when I'm doing 40 to 49, I'm looking to see how many there are. 1, 2, 3, 3. So 1, 2, 3, 3. 50 to 59. 1, 2, 3, 4, 5, 6. 6. 60 to 69. 1, 2, 3, 4, 5, 6, 7. 7. 70 to 79. 1, 2, 3, 4, 5, 6, 7, 8. 80 to 89. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 14. And then 90 to 100. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so it looks something like that. So we've created our histogram plot. And then we can kind of see if we're looking at this, if this is a normal distribution and all of that. And it's clearly not, it's clearly skewed to one side. You know, we do have a mode right here, but this is not a perfect bell curve, right? There's far more on the lower side than on the upper side, so we know that this is not normal. But from this, we can then answer the rest of the questions. Okay, let's go ahead and turn the page. Okay. So for the set, whoops, let's move this down. For the set, we're going to be using features of normal curve to rank data. So we got 5 track athletes and they're running for the Athletic Performance of the Year award. A panel of coaches is trying to decide which athlete is the most deserving to win the award. Rank each athlete below by the given information, okay? Assuming all distributions follow a normal curve. That's an important thing. So Javier threw the javelin 215 feet. The average javelin throw was 152.08 feet with a standard deviation of 15.85. So let's go ahead and figure out what the z-score is. Let's figure out what the z-score is, right? And to find the z-score, what do? I'll do it in the margin here. We take our data point, we subtract our mu, and we divide by the standard deviation. So I'm going to take 215, subtract the average 152.08, and then divide by the standard deviation 15.85. I have a feeling this is going to be a very high z-score. 215 minus 152.08 is 6292. Divide by our standard deviation 15.85. We get a very high z-score. We get a z-score of 3.9, and then I'm going to round this up to a 7. Okay, that's a pretty large number. Okay, let's look at Chase. All right, Chase ran a 400-meter time in 46.99 seconds. The average of the 400 meters 52, with a standard deviation of 1. Okay, so we set it up exactly the same way. Here's our data point, so 46.99. We subtract the mean. 52.6, standard deviation of 1.01. Okay, so we just do all that. 46.99 minus 52.6, divide that by 1.01. We have a very slow time, a very slow z-score of negative 5.55. Okay. So right now, if we were to rank them, Javier is way ahead of Chase because the z-score is way better compared to Javier's peers than the z-score of Chase is compared to his peers. Okay, let's look at Derek. Same deal. Here's our n. Here's our mu. Here's our sigma. 36.26 minus 41.77. Going to be another negative time. 1.49. So let's go ahead and just calculate that. 36.26 minus 41.77 divided by 1.49. We get a z-score of negative 3. Well, that 7 is going to round that up to a 10, which is then going to round that up to a 7. So 3.70 is our z-score. Okay. So right now this is in between the other two if we were to rank them. Okay, Derek's in between. So on and so forth. So for D and for E, you would then find their z-scores and rank them accordingly. As it stands right now, if we just had A, B, C, if I were to rank them, My lowest rank would be B. My lowest rank would be B, Chance, with the negative 5.5. My next would be C, Derek, with a negative 3.7. And my highest would be A, Javier, with a 3.97. Now, depending on how Chad and Caden do, they will fit somewhere in that. Okay, depending on what their z-scores is, or z-scores are, it'll fill in from there. Okay. Finally, this one, solving logarithmic equations. I forgot to do this on this particular handout. Hopefully in future units I will remember, but this is going to be optional as it's review of last term, and you may not have had this course last term. So we'll call that good. We'll call that optional for now. And that'll do it. Good luck on these z-scores. Make sure you're calculating these z-scores. I know it's a bit of a challenge, but calculate the z-scores, use the z-scores, so on and so forth. Double check your notes, search around if you're not exactly sure what the z-score is telling you. All right, have a good one.